Find the volume of the solid when the region bounded by y is equal to the quantity 2x raised to the 1/2 power, and y is equal to 1/2 times x squared is rotated about the line y equals 0. Well, since these two functions and the region in between them is being rotated about the line y equals 0, both of these functions have to be put in terms of x, and they already are in terms of x. So now let's try to graph them and determine our lower and upper bounds for integration. So y is equal to 2x quantity to the 1/2 power is equivalent to y is equal to the square root of 2x underneath of the radical. And the other one you can rewrite as y equals 1/2 x squared. Okay, so we can actually make t-charts for both of these to get a few points so that we can visualize what's happening here. So xy, xy. Okay, so if we substitute 1/2 in for x in this one, 2 times 1/2 is 1, and the square root of 1 is 1. If we substitute 2 in, 2 times 2 is 4, and the square root of 4 is 2. So we're going to have, and then if we did 0, we would end up getting 0 as an output also. So we have 0, and then 1/2 and 1, and then 2, 2. So it's going to look something like this. Okay, now let's do 1/2 x squared. So we can do 0, 1, and 2, since there are really no restrictions on squaring. 0 squared is going to be 0 times 1/2 is still 0. 1 squared is 1, but 1 times 1/2 is 1/2. And 2 squared is 4. 4 times 1/2 is 2. So now we can plot these points. So we have 0, 0, 1, 1/2. And then 2, 2 is still this point. So we're going to have a graph that looks like this. So we can see this section of the graph is what we're going to be rotating about the line y equals 0, or the x-axis. So it's going to look something like this when we revolve it around. And we can also clearly see from our graph and from our table that our bounds for integration are going to be 0 and 2. So our volume is going to be pi times the integral from 0 to 2. And now we have to determine the outer radius. Since we're going about the x-axis, the outer radius or the upper radius is going to be the square root of 2x. So square root of 2x squared minus the inner, which is going to be 1/2 x squared, and we're going to square that too. And we're going to integrate this with respect to x. So we still have pi times the integral from 0 to 2. And the square root of 2x squared is going to just be 2x minus 1/2 squared is 1/4, and x squared squared is x to the 4th. Now when we integrate, we'll have pi, the integral of, the integral of 2x will be 2x to the 2nd over 2, or just x squared, minus x to the 5th over 1/4 times a 5th is 1/20th, or over 20. And we're going to evaluate this from 0 to 2. So we have pi times, we're going to have 4 minus 32 over 20. And then minus, well, if I substitute 0 in, it's going to just give me 0 in that part. So we have pi times 4 minus, this reduces to 8/5 or 1.6. And that's going to give us 2.4 pi. If you left it as a fraction, it would have reduced down to 12 pi over 5. And that matches answer choice C.